What if the age on your birth certificate isn't your true age? Imagine discovering your body is actually a decade older or younger than you think. This isn't science fiction or wishful thinking. It's the reality of epigenetic clocks, the secret timers ticking inside every cell of your body, revealing your biological age and offering tantalizing clues about how you might be able to slow them down or even reverse them. For most of human history, we've measured age by counting birthdays. It's simple, straightforward, and utterly insufficient. Two people born on the same day can have dramatically different health trajectories. One might be running marathons at 70, while the other struggles with chronic disease at 50. The calendar doesn't explain this discrepancy, but your epigenetic clock does. Beyond birthdays, your real age revealed. The distinction between chronological age and biological age represents one of the most important concepts in modern longevity science. Chronological age is simply the number of years since you were born. Biological age, however, reflects the actual condition of your cells, tissues, and organs, how much wear and tear your body has accumulated regardless of how many candles were on your last birthday cake. At the heart of this biological clock lies a process called DNA methylation. Your DNA serves as the instruction manual for building and maintaining your body, but not every gene is active at all times. Methylation acts like a system of molecular sticky notes attached to your DNA, telling certain genes when to turn on and when to stay silent. These methyl groups, small chemical tags consisting of one carbon atom and 3 hydrogen atoms, attach to specific locations along your genome, influencing which proteins get made and which remain dormant. Here's where things get fascinating. The pattern of methylation across your genome changes predictably as you age. Certain sites gain methyl groups while others lose them, and these changes follow such a consistent pattern that scientists can actually read your methylation patterns like tree rings, estimating your biological age with remarkable accuracy. This methylation pattern serves as a molecular record of your lived experience, tracking not just time but the accumulated effects of your lifestyle, environment, and health choices. Why does this matter? Because biological age predicts health outcomes far better than chronological age. Research consistently shows that people with accelerated biological aging, those whose epigenetic clocks tick faster than their birthdays suggest, face higher risks of cardiovascular disease, cognitive decline, cancer, and earlier death. Conversely, those with younger biological ages enjoy extended health spans and reduced disease risk. Understanding your biological age provides a window into your future health that chronological age simply cannot offer. The science of cellular timekeeping. The modern era of epigenetic clocks began in 2013, when UCLA geneticist Steve Horvath published a groundbreaking study that would reshape our understanding of aging. Horvath had analyzed DNA methylation data from over 8,000 samples representing 51 different tissue types and, through sophisticated computational methods, identified 353 specific methylation sites that changed so predictably with age that they could estimate someone's age with striking precision. The Horvath clock, as it came to be known, could predict chronological age within about 3.5 years, an astonishing achievement that immediately captured the attention of the scientific community. But perhaps more importantly, the discrepancy between predicted age and actual age proved medically meaningful. People whose Horvath clock showed them as biologically older faced measurably worse health outcomes. Since Horvath's initial discovery, numerous additional epigenetic clocks have been developed, each with different strengths and applications. The Hannum clock, developed around the same time, used different methylation sites and blood samples specifically. More recently, second-generation clocks like GrimAge and PhenoAge were designed not just to predict chronological age, but to directly predict mortality risk and health span. These newer clocks incorporate additional biomarkers and have proven even more powerful at identifying who is aging well and who is aging poorly. The real-world implications become vivid when you examine individual cases. Researchers have documented people whose biological age runs a full decade younger than their chronological age, and these individuals consistently demonstrate better cognitive function, stronger immune responses, and lower incidence of age-related disease. Others, tragically, show biological ages far exceeding their years, And these accelerated agers face health challenges that their birth certificates wouldn't predict. It's crucial to understand that these clocks are measuring something beyond simple prediction. They're capturing the accumulated cellular damage, the efficiency of repair mechanisms, and the overall functional capacity of your biological systems. When your epigenetic clock runs fast, it's not just a number, it reflects genuine cellular wear and tear that manifests as reduced organ function and increased disease vulnerability. Unmasking the accelerators of aging. If biological age can diverge so dramatically from chronological age, the obvious question becomes, what's driving that divergence? Research has identified several key factors that accelerate epigenetic aging, and unfortunately, many of them are distressingly common in modern life. Chronic stress stands as one of the most potent accelerators. When you experience ongoing psychological stress, your body maintains elevated levels of cortisol and other stress hormones. This persistent stress response creates oxidative damage, promotes inflammation, and directly influences methylation patterns in ways that speed your epigenetic clock. Studies of caregivers, trauma survivors, and individuals facing chronic adversity consistently show accelerated biological aging compared to their peers. Sleep deprivation compounds the problem. During quality sleep, your body performs essential maintenance and repair operations. DNA damage gets fixed, cellular waste products get cleared, and critical proteins get replenished. Chronic sleep restriction, whether from insomnia, sleep apnea, or simply choosing to stay up late, interrupts these repair processes and accelerates cellular aging. Research has demonstrated that even moderate sleep restriction can measurably advance epigenetic age over time. Dietary choices play an enormous role as well. Ultra-processed foods laden with refined sugars, industrial seed oils, and chemical additives promote inflammation and oxidative stress throughout the body. These foods provide calories without the vitamins, minerals, and phytonutrients your cellular machinery needs to function optimally. The resulting nutritional deficiencies and inflammatory burden directly influence methylation patterns and accelerate biological aging. Environmental exposures add another layer of assault. Air pollution, cigarette smoke, industrial chemicals, and even excessive sun exposure all contribute to accelerated epigenetic aging. Urban dwellers consistently show faster biological aging than their rural counterparts, partly due to higher pollution exposure. These various accelerators converge on a common pathway scientists call inflammaging, the chronic, low-grade inflammation that develops with age and drives many age-related diseases. Unlike the acute inflammation that helps heal a wound, this persistent inflammatory state slowly damages tissues throughout the body, from blood vessels to brain cells. Each of the factors mentioned above, stress, poor sleep, bad diet, and environmental toxins, promotes inflammaging, and inflammaging accelerates the epigenetic clock. The consequences manifest as the diseases we associate with getting older: atherosclerosis, type 2 diabetes, Alzheimer's disease, arthritis, and cancer. These conditions don't simply happen because you've lived a certain number of years. They emerge when accumulated cellular damage exceeds your body's repair capacity, when your biological age has advanced beyond what your systems can handle. Rewriting your biological clock. Proven strategies. The good news is that biological age isn't fixed. Unlike your chronological age, which advances relentlessly at 1 year per year, your biological age responds to your choices. Research increasingly demonstrates that the right interventions can slow, halt, or even reverse epigenetic aging. Dietary interventions offer some of the most robust evidence. The Mediterranean diet, rich in olive oil, fatty fish, vegetables, legumes, and nuts, consistently associates with slower biological aging in population studies. The abundant polyphenols, omega-3 fatty acids, and fiber in this eating pattern reduce inflammation, support cellular repair mechanisms, and favorably influence methylation patterns. Caloric restriction and intermittent fasting have shown particular promise. When you reduce caloric intake or extend the periods between meals, you activate cellular stress response pathways that enhance repair and maintenance processes. Autophagy, the cellular cleanup mechanism that removes damaged proteins and organelles, gets upregulated during fasting periods. Animal studies consistently show that caloric restriction extends both lifespan and health span, and human trials are beginning to confirm these effects through measured changes in epigenetic age. Certain supplements have attracted significant research attention. Nicotinamide mononucleotide and nicotinamide riboside, precursors to the vital coenzyme NAD+, have shown promise in animal studies and early human trials. NAD+ levels decline dramatically with age, and restoring them appears to support mitochondrial function and DNA repair. Resveratrol, the compound found in red wine, activates longevity-associated proteins called sirtuins. While the research remains ongoing, these compounds represent exciting potential tools for biological age reversal. Physical exercise may be the single most powerful intervention available. Regular movement reduces inflammation, improves insulin sensitivity, enhances mitochondrial function, and directly influences epigenetic markers. Both aerobic exercise and resistance training contribute unique benefits, and the combination appears optimal. Importantly, it's never too late to start. Exercise benefits epigenetic age regardless of when you begin. Stress management and quality sleep complete the lifestyle picture. Meditation practices have been shown to reduce cortisol levels and favorably influence methylation patterns. Prioritizing 7 to 9 hours of quality sleep allows your body to complete its nightly repair cycles. These aren't luxuries or nice-to-haves, they're essential components of biological age management. On the frontier of longevity research, scientists are exploring even more aggressive interventions. Senolytics, drugs that selectively eliminate senescent zombie cells that accumulate with age and drive inflammation, have shown remarkable effects in animal models and are entering human trials. Gene therapies targeting specific aging pathways are under development. While these remain experimental, they point toward a future where biological age becomes increasingly malleable. The future of longevity, your toolkit for a longer health span. The trajectory of epigenetic clock technology points toward increasingly personalized longevity medicine. Already, companies offer at-home methylation testing that allows you to track your biological age over time. As these tools become more affordable and accessible, you'll be able to see in near real time how your lifestyle choices influence your cellular age, adjusting your approach based on actual measured results rather than general guidelines. The vision of personalized epigenetics extends beyond simple measurement. Future applications may include tailored nutritional recommendations based on your specific methylation patterns, exercise prescriptions optimized for your biological needs, and targeted supplementation addressing your individual cellular deficiencies. Medicine will shift from treating disease after it appears to preventing biological aging before disease develops. But you don't need to wait for that future. The science is clear enough today to take meaningful action. Start with the foundational behaviors. Prioritize sleep, manage stress, move your body regularly, and eat real food rather than processed products. These interventions cost nothing, carry no side effects, and offer benefits that extend far beyond epigenetic age. Consider your current lifestyle honestly. Are chronic stress, poor sleep, or dietary shortcuts silently advancing your biological clock? Small changes, consistently applied, compound over time. The person who exercises moderately, sleeps adequately, and eats reasonably will almost certainly enjoy a younger biological age than the person who does none of these things, regardless of genetic starting points. Your chronological age will continue advancing at its inexorable pace. But your biological age, the age that actually matters for your health, vitality, and longevity, remains substantially under your control. The clocks are ticking inside every cell, but you hold more power over their pace than you might have imagined. The question isn't whether you can influence your biological age, it's whether you'll choose to do so. Perhaps most encouraging is the growing body of evidence suggesting that epigenetic changes aren't permanent. Unlike mutations in your DNA sequence, methylation patterns can be modified. Studies have documented measurable reductions in biological age following lifestyle interventions lasting just weeks to months. Your cells retain a remarkable capacity for renewal when given the right conditions. The concept of biological age transforms how we think about growing older. Aging isn't simply the passage of time, It's a biological process influenced by countless factors, many of which lie within your control. Understanding this distinction empowers you to take an active role in your own longevity, rather than passively accepting decline as inevitable. Every choice you make either advances or restrains your epigenetic clock. The meal you eat, the sleep you prioritize, the stress you manage, and the movement you embrace all leave their marks on your cellular machinery. Over months and years, these choices accumulate into dramatically different biological ages and health outcomes. The science of epigenetic clocks has given us something unprecedented: a window into our biological futures and a roadmap for changing course. We are no longer prisoners of our birth dates or hostages to genetic inheritance. The true measure of our age lies in the molecular patterns written across our genomes, and those patterns respond to how we choose to live. Your biological clock is counting, but you get to influence what it counts.